Arc Junkies presents Weld Wednesday with AWS, brought to you by the American Welding Society. And now your host, Jason Becker.
All right, ladies and gentlemen, joining me today is Anthony Nighswander from APT Manufacturing. He is the founder and I would imagine CEO of the company.
That's right. Yep.
Anthony, it's great having you on the show. We got to meet at the Welding Automation Expo for AWS up in Minneapolis last month. I attended your seminar, and I was actually looking for somebody to talk about automation and education. And after I heard your presentation, I was like, man, I really need to get a hold of this guy and talk to him, get him on the podcast because you're super passionate about the work that you do, and that's rare. You know, a lot of people, they wake up, they go to work day in, day out. You know, they clock in, they clock out, they leave work at work, and they leave home life at home. But you kind of demonstrated a true passion for the work that you do. You're obviously passionate about it because you started an entire company around automation and education. So first, thank you for your presentation. It was awesome to attend. And second, thank you for joining us on the podcast today.
Well, thank you. I appreciate being invited. And this is a good opportunity to just be able to talk to industry folks and also education folks. And they really go hand in hand. Industry is begging for employees and education saying, well, how do you want them trained? What do you want? And so I think this will be a good opportunity for me and you to have a conversation and talk about both sides of it. But how does education get started in robot welding? We've been doing welding for years, and that's awesome. And that is the foundation of everything. But how do we get started in robot welding, and what does industry need? And I think those are some good topics for today.
Yeah, and like especially right now because automation is kind of taking the industry by storm. I know I started teaching in 2016. We had a robotic ed cell, and it was so complicated to learn. It was very intimidating. I wanted to learn about it. I went to classes to learn about it, and I just didn't have the time to put into that piece of equipment and teach a class and develop curriculum and do all the things. It was like, yeah, automation would be nice to add to the program. But, you know, me coming from a structural steel background, not an automation background, like I don't know how to operate this thing. So I know there's a lot of other instructors out there as well that they're severely intimidated by the equipment because they don't have any experience with it whatsoever. But now they're so easy to use.
Right.
Does it make sense for a school because of the ease of use? Does it make sense for a school to get a robotic trainer and bring it into their facility and train students to enter industry and have that experience? Or is it something you can just, you know, get hired on somewhere and they can teach you day one how to operate the teach pennant and go through the robotic system?
Yeah, so I think it's really important for schools to have robotic welding classes in their class. That's been growing so much. It's kind of incredible. And if we back up, when you mentioned, I believe 2016, when you were a teacher and you're looking at how do I teach this class, what you had and the opportunities you had there is what we call traditional robots. And I'm a FANUC integrator, so it would be the yellow robots, and that's what I would prefer to. But it doesn't have to be FANUC. It could be Motoman that's now Yaskawa. It could be ABB, and we're just calling those traditional robots. And then life changed, and people, the slang word is cobots, but it's really a collaborative robot. So it's still a robot, but it's a collaborative form. Biggest difference is, let's talk about safety. The biggest difference in safety is it no longer needs caged. It's got sensors on it. So now instead of having this animal in a cage, if I get in there in the cage, it's gonna go from point A to point B, whether I'm in its way or not. Now we have a collaborative robot that if I get in its way, it's going to sense me and it's going to stop. And so that's been a game changer in schools. So in 2016, maybe industry came to you and said, we need robotic welding, but the industry that came to you was a high volume, low mix industry. So if that wasn't in your town, that wasn't in your area, you were like, I don't know if I can teach robotic welding. Today, with the collaborative robot market, it's unbelievable that every fab shop is looking at how do I automate. If they have 10 employees, they're saying, wow, I can't get an employee. Maybe I can automate with a cobot. What's a cobot? How do I work a cobot? What do I do with this thing? Does the schools teach on it? And that's what I continue to talk about and work with schools on. Would I buy a robot or would I buy a cobot? And if you'd like me to, I can share the difference in those.
Oh, please do.
So the biggest thing is to understand is a cobot is a robot. It's still a 6-axis, 6 servo motors. And it's in a collaborative form. So each servo motor in the FANUC world, each servo motor has its own sensors on it to be able to detect any safety issues. A collaborative robot is much easier to teach because students today, people today, we all are. My dad's 92 years old and he's used to an iPhone, right? So iPhone changed the world on apps and how do I use it? And that's what's happened in the collaborative world is we're using timeline programming. So we're now dragging and dropping what we want. What does that mean? So I'm gonna put the cobot or the collaborative robot in teach mode, and I'm going to grab it and I'm going to say, this is my start position. And I'm going to drag in a start position. I'm going to move the cobot to a next position. I'm going to say, I'm going to wrap it to here and it's going to wrap it to there. And then I'm going to put in maybe let's say a stitch weld and I'm going to drag in a stitch weld and it's going to pop up and say, how many stitches? What's my start point? What's my end point? How many stitches? And do you want them equally spaced or do you not? And then how do I return? I want to return back to the home position. And that's how easy it is, and it does all the calculations. Now, let's just say that you had automotive or you had the ag world in 2016. They were using, and they still are using, robots. So is robots important to teach? Yeah, robots are important to teach as well, because for the high volume, low mix, they're going to use a yellow industrial traditional robot all day long. For the high mix, low volume, the fab shops, they're going to use a collaborative robot. But let's talk about how I would implement that in my school. Which one would I buy? Schools all the time call me and say, hey, what do I want to buy? Do I want to buy a cobot or do I want to buy a robot? I used to say, it depends upon what's in your area. What are you teaching for? Where are your students going? Because really, what it comes down to is you're selling a product and your product happens to be the school or the student. I'm sorry, you're selling the product and it happens to be the student. And if me, the consumer, goes to a grocery store and I get bad eggs, I'm probably not going to go back to that grocery store. It's no different for schools. If I'm not getting a quality student coming out of a school, I'm probably not going to go back to that school and try to pull more from them because I'm not getting that quality, right?
Yep.
And so I tell schools all the time, you are producing a product, and that product that you're producing is a student. Ironically, that student's paying for that. So my goodness, if they're paying for it, they really should get a quality certification, AWS certification, a FANUC certification, whatever. And we can talk a little more about certifications as we go through. But today I say you should probably get a cobot in there if I'm talking FANUC, and I don't know all the other ones. And the reason I say that is FANUC's cobot, you can put it in legacy mode or collaborative mode. You can teach traditional or you can teach timeline. You don't need two robots in there. You don't need a yellow robot in your class and a cobot in your class and the yellow robot sitting in a corner. You should teach on both. In fact, FANUCs, you can unscrew the tablet and screw in the traditional teach pennant, and you are 100% programming it like you would a traditional yellow robot. So to me, if I advised a school, I would say all day long, put in a collaborative robot that can do both. And that's why I'm not trying to be biased to the FANUC world. I only know the FANUC world, but if other ones can do both, put in to do both and just put in a cobot. Now you've got a safe system. It's easier to start teaching a student on the collaborative world because they start to understand it and they get excited. They're not like, I'll never do this. And so now they get excited. And if they want to go one step further, or the industry in your area is using the traditional robots, well, then now you have an opportunity to do both. And I know from me, I'm a welder by trade. My goodness, I have controls engineers that program those traditional robots. That is not my forte. Let me just lay a bead. That's not me. But when it comes to collaborative robots, totally different. Now I'm excited about doing it because I can accomplish something instead of having to go back and think about everything that I'd have to do. So
yeah, I remember having that in my classroom. We had the traditional robot set up. It was a Lincoln Electric Ed Cell. Fantastic machine.
Yep.
If you knew what you were doing.
Yep.
And I would grab that teach pendant and I'm kind of going through the book, because they have a little workbook to teach you how to use it and everything. So it's like, okay, page 1, power on, go through this thing. And as I'm going through this, it's like, okay, Z negative, Y positive, X negative, just trying to get this arm in the correct position to get the arc length and the travel angle and the work angle that I'm going to need, my start point and end point. And I kept thinking to myself, I was like, why can't I just grab the head of this gun and just drag it where I want it and just say, hey, I want you to start here, and then drag it to where I need to stop and say, stop there. And lo and behold, a few years later, they come out with these cobots where you literally just push a button and it kind of loosens that arm up and you put it exactly where you want. And you say, hey, start here, end here, whether it's going to be, a radius or a straight line or stitch weld or whatever. So they made it so much easier. So I could see the benefit of having a system like FANUC where you could teach the cobot aspect of it, to where you can just grab that head and move it around, or you could go back and teach the traditional, XYZ or Cartesian coordinates, and be able to run it that way. Cause that's cobots, like, that's like the buy-in. It's easy to get somebody in there. It's easy to train them with that. And you could say, hey, now let's go to the traditional side for, an arm that you can't just reach up and grab. Cause I've seen some of these robotic arms that they're 3 stories tall.
Oh yeah,
You're not going to go
absolutely.
reach up and grab the head of that thing when it's, meant to move vehicles around and all that stuff for the given application. But now having that ability to use a teach pendant and kind of break down that line of fear of learning with the cobot. Okay, now you're used to this system, you're used to the teach pendant, and now swap things over and let's show you the traditional method. So I think that's a huge benefit because both of those, like you were saying, both of those technologies are still used in industry today. It makes sense to put a cobot for this situation, but it makes sense to put traditional robotics into this situation, where you can't just grab a hold of that and kind of move it around. But
Yeah, I think the other difference on that too is the person that we're training. So in the traditional yellow robots, you're really looking at a controls engineer that's doing the programming,
Mhm.
but a controls engineer doesn't always understand welding.
Right.
So now the welder's standing beside the controls engineer and saying, you have no idea what torch angle is, right? And because when you go to school making a decision, you go to college or high school making a decision of, I want to be a welder. You didn't go to the welding class to be a controls engineer. You went to the welding class to be a welder.
Mhm.
And so by adding the collaborative robot in, the absolute best collaborative robot programmers in welding is the welder. It's not that way for traditional robots. There's a lot more going on. But on a collaborative robot, the welder is the best programmer and they just absolutely fall in love with it because they understand welding. Makes a huge difference.
Yeah. In a lot of people, they're afraid that they're not going to, or they're going to be replaced by robots. But from all the manufacturers that I talk to, they're like, no, as soon as we get a robot or a cobot in, we actually need to hire 3 or 4 more welders. So it's
Hmm.
actually creating jobs. And that's what I would always tell my students, don't be afraid when you're working with these different companies. They're going to they're going to start tooling up to increase production because at the end of the day, more production, faster way of doing things, the more parts we can get out at a lower cost, the more money we can make. So they're going to figure out how they're eventually going to automate, especially if they have like high mix, low volume parts and stuff like that versus paying a welder to crank out 30, 40 parts a day. Well, if I can incorporate a cobot and crank out, 100, 200 parts a day, that's what I'm going to do. But now you as the welder, you are like the subject matter expert in the thing, right? The widget requires the welding. Yes, the cobot can do the welding, but now it's up to you to teach that cobot how to do the welding. Like you said, a lot of the welders, they make the best programmers for these cobot situations because they understand work angle, torch, contact tip to work distance, travel, all the variables, amps, volts, wire feed speed, the whole 9 yard. Whereas a traditional programmer, they could get the robot to do things, but when it comes to the welding aspect, they're going to have a hard time putting down quality welds and troubleshooting, certain discontinuities that come up. Whereas a welder's like, oh, we're getting some porosity. Okay,
Yep.
we got a gas issue or something to that effect, or contact tip to work distance is too far out. So a lot of your welders, they're going to make the better programmers when it comes to those instances.
Yeah. We've got a customer in New York, upstate New York, and we put in 4 collaborative robots, and they were doing stainless steel. And I went in and visited them a couple months after they had them in, and they were running them. And I said, "Has your production increased?" And he said, "Yeah, in areas that I didn't expect." And I said, "Well, what do you mean?" He said, "Well, my production increased on welding because 6 o'clock in the morning and 4 o'clock in the afternoon, I'm getting different output because people are getting tired. It's hot. It's not consistent. And he said, but not only am I getting better production, but my grinders are doing less. And I'm like, oh, he said, like we hardly grind apart anymore because it's laying such a perfect bead once we locked it in time after time after time after time. And I said, that's really funny. And the gentleman was not a welder by trade. He was the operations manager. And I said, that's kind of funny because in the weld world, you try to figure out it really quick. Are you a grinder or are you a welder? And you want to be a welder, not a grinder, right? And so it was interesting that not only did they gain profit on the welding, but they also gained it on the grinding. And he didn't expect that, and I didn't sell it that way at all. And so very interesting of what the collaborative robots are doing.
Oh, it makes a lot of sense too, because you've got a lot less rework at the end of the day, ideally,
Right.
because the robot's so consistent. So if you can put the parts in there the same way every time, you get them locked in, you set your points and all that stuff. And I think a lot of the robots, cobots, they you can actually put the parts in up to 15, 20 degrees off of center, and it'll find exactly where to start on that part. But it's the
Yeah, so
consistency
let's
that's
talk a little bit about that. So it was interesting when FANUC launched their cobots in 2020. We told FANUC, we integrators told FANUC, all we wanted to do is this. Well, then they did whatever that was, and then we're like, no, we want this, we want this, we want this, we want this. And at the end, FANUC's like, well, what you really want is a yellow robot, all the functions of a yellow robot on a cobot. And we're like, yeah, we really do. And so they've done that. So what's interesting today is this software that comes with the robots, and then we can also add laser on top of that. So if we just talk a little bit about that, FANUC has what's called TPW or thick plate weld, and that comes with three pieces of software in that package. The first is touch sensing. So now I can touch on one side, on another side, and it knows right where the V is. I can go to the endpoint and do the same thing. After that, I can do through-arc seam track. Through-arc seam track is really I've got to program the robot to do a weave, and I'm going to check the voltage at the top and the bottom of the weave. And as the part warps, we're just going to follow that warp, and it's going to overwrite the original program. And then the last piece of that is root memorization. And so those are the three things that FANUC offers inside of the robot. Now let's just go a little bit further and say, I'm putting on some parts onto a large frame, and the lugs that I'm welding aren't always in the same place. They're tacked on or they're placed in, but they're not in the same place. Now I can use a laser seam track, a laser seam find, and the laser will actually take over the whole program. So what I then do is I program the robot to be in a relatively close place, like within a half inch, beginning and end. And then I turn the laser on, and the laser writes the whole program as it's welding the lug on or whatever it is. It's really important when you're doing saddle joints. Saddle joints are really tough to do with a cobot or a robot because it's down, around, up, around, down, around. And so by using a laser, we can literally touch off about 6 or 8 points going around. It gives the robot or the cobot, well, this is close. I kind of know what I'm doing. And the laser completely takes over. So the technology today that we use in cobots that we used to use only in robots are now in cobots, and teachers can teach that as well on our equipment.
that technology blows my mind because it's very similar to a welder watching the joint as they're going through, and they see the warpage and they can kind of increase oscillation or manipulation to kind of fill in that gap or avoid that distortion. But now robots, through like you were saying, seam tracking, and the addition of the laser. I didn't know about the laser. I knew seam tracking. I'm
Yep.
familiar with
Yep.
that and the vision software. But yeah, now they're incorporating lasers to determine
Yeah.
where the center of that joint is, and it fascinates me and blows my mind that technology's actually available, and that robot can on the fly reprogram itself in real time to make adjustments to still produce a quality part when the fitment may not be 100% correct.
Right. Right. I was in FANUC's lab a few weeks ago at Rochester Hills at their headquarters, and they had a particular product from Servo Robot on the robot in the welding lab, and it was listening to the weld, and it was making adjustments as it was listening to it. And I'm like, no kidding. And he said, yeah, you know how you can walk by a welder and you're like, that's a bad weld
Yep.
because you're just hearing it. Now, the weld might not be in the right place. Maybe it missed the seam, but wow, that was a nice bead because you can hear it. And Servo Robot has come out with a product that it actually listens to it and makes adjustments, speeds and feeds, wire speeds and the feed of the robot as it's going around, which to me, there again, it's mind boggling, right? It blows my mind.
That's crazy. Now, I know for the most part, robots and cobot systems have just been kind of limited to flat and horizontal welds. Are they taking robotic applications and applying them to vertical and overhead conditions as well?
They absolutely are. And in fact, I was in FANUC's lab a few weeks ago and they were doing that. And they wrote some programs that'll probably, I would say, normally what they do in their lab and then it comes out on an app on the timeline programming. But they are, when you're doing a vertical up, there's a triangle that you're doing there. And they're repeating that triangle and doing a really, really good job of doing the verticals and the overheads.
No, that's awesome. I would tell students, like, think about how a robot does things, and that's how I want you to weld, because all it is, it's a repetition. So once you figure out that manipulation, once you figure out how to walk and chew bubble gum at the same time, it's the same thing over and over again. So I would try that. I would train them with that triangle weave, especially like a pulse MIG going vertical. You got to run that little triangle shape to be able to manipulate and control that puddle. And all it is it's like, I would equate it to a metronome, because they could kind of get that sound in their head to be able
Yep.
to replicate that over and over again. And then it's just kind of dialing their wrist movement in. Whereas a robot, it's just doing the same thing. It's able to move ABC the whole way up.
Yeah. Yeah.
No, that's very
So
fast.
you mentioned let's go back to the education market once and let's talk about how do I start? What do I do? And maybe I should give a little bit of my history. I started APT Manufacturing in a garage 30 years ago. It was 1996. And we've grown to be one of FANUC's largest integrators. There's, I don't know how many people, some people say 1,000, some people say 1,200, but I'm in the top 10, 12 integrators in the United States. Um, so in 2012, 2013, I was growing and growing and growing and growing. And I started a high school training program. Why did I start a high school training program in industry? Shouldn't the schools been doing that? I actually called in my local career center and I called in my community college and I brought them here and I gave them a tour and I said, this is what I need. I need tool makers, I need welders, and I need kids with a teach pennant in their hand. And they got excited and I said, would you like to go to FANUC headquarters? So we scheduled FANUC headquarters. And when we went to FANUC headquarters, they got all excited and they did nothing. They literally did nothing. And we've talked prior to this, we talked about grants and how do I get involved? And they did nothing because they didn't have the money to do it or the resources to do it. It was about 6 months later, I met Paul Aiello, which is the director of FANUC Education for all the Americas. And Paul came and visited me here and he said, Tony, I've got an opportunity to partner with any integrator in the United States to help build advanced equipment for education. But you have such a passion for education because you started your own high school training program. And when I started the program, it was a little bit different because I started them. Really, the first thing they did is what's a mic? What's a caliper? Just simple. What's a tape measure? How do I read these? How do I do these things? And the second thing was safety. And the third thing was engineering. And the college told me, you can't do engineering. That's a sophomore. That's a junior. I said, no, engineering starts in the mind. It doesn't start on a computer.
For sure.
And you have to be able to visualize everything there is in 3D. So very few times in welding do we weld in 2D. We're building something, right? I don't know. We're building a box. We're building a wall. We're building a building. And it's all in 3D. So we taught our students to think in 3D. And from then, they went through everything in my company, mechanical first half of the year, electrical second half of the year, and then they chose what they wanted to do the second year, and if it was electrical minded or mechanical minded. And then we started an apprenticeship program. And we pay for everybody's, anybody that hires in here, we pay for their college and they go through an apprenticeship program. It's not an option. If you don't want to go through an apprenticeship program, you're probably not the right person for me. And so we started an apprenticeship program. And when Paul came to me, I said, Paul, you know what? I'll build FANUC's education equipment or training equipment as long as I cannot, long as you don't force me to cut corners. So forget about cost. And it's got to be built exactly the way industry wants it built, because we're producing this product that we talked about earlier.
Mm-hmm.
And so Paul said, no problem. And we built one piece of equipment, and then we built another one and another one and another one. And today we have an LMS system called ITA, which is Industry Training Academy. We have a full line of equipment, mechanical and welding both, just to produce that student. But how does a school get started? Is there grants available? So FANUC has a $400,000 grant available to the schools if it's their first welding robot in that location. That $400,000 is not cash. That's all the software. That's all the RoboGuide licenses. All the software is for free, not just their first robot, but all of the robots that come into that welding class. All their software is for free. All their RoboGuide licenses for free. I believe in high schools it's like $1 renewal, and in college it's $100 renewal per year. Me, in industry, this cost me $10,000 per license. And for the schools, they get 25 of them for nothing.
Wow.
So that's $250,000 of that grant. They used to call it a gift in kind as they were gifting it. FANUC changed that. Paul Aiello changed that a few years ago to a grant, and that allows a school to do a matching grant. Now, when we get industry involved, and industry says, I'll put in $50,000, can you match that somehow? As long as we match it, now they can use FANUC's grant as a matching grant up to $400,000. Now a school can get $400,000 in cash, and they can get the $400,000 grant from FANUC to use as a matching fund. So that's pretty incredible. That only happens through FANUC's, what they call their ESP network, or their education solution providers. And the reason that is those solution providers work really hard with state grants, U.S. funding, government funding, and along with the FANUC grants, and they understand how to do the matches and things. So, yeah, there are ways to get involved and to get started.
Now, does that grant also include the capital equipment? So you mentioned
It does not.
licenses.
Nope. So that's usually where the matching grant comes in.
Okay.
Hey, industry, I've got a $400,000 grant from FANUC for all the software, all the RoboGuide, everything. And industry understands RoboGuide. Everybody in industry uses RoboGuide. And so I've got this grant from FANUC. Can I get a matching grant? Can you guys match that 400? And usually industry will be like, well, between 4 companies we will, or between 8 companies we will. And that's where the funding can come from.
Gotcha. Do you know, like, what, I know this is going to be an odd question, but just like ballpark, because I haven't been pricing equipment out lately, but what does like an average robotic or cobot sell, you know, like a trainer version, what does that typically cost?
Yeah, so our mod weld, it's the same exact mod weld or cart that we use in industry and we use in education both, because I don't build anything different. It's always the same. The average cost on that is right around $100,000. It could be a couple thousand less, couple thousand more, but right around $100,000 for the mod weld cart. In education, that comes with the FANUC CRX 10, and in industry, it comes with the 10L. What's the difference? Well, they're both industrial cobots, but the 10L has a 55-inch reach, and the 10 has a 50-inch reach, and the 10's a couple $1,000s cheaper. So there's nothing different. It's not an education one, or it's not a dumbed down one. In industry, we decide, do we want the 10 or the 10L, depending upon the application. And in education, we just save them that money.
I got you.
And then I can put on a Miller Fronius or a Lincoln power supply on that piece of equipment, whatever this school wants to use.
Okay. Yeah, because I know AWS has their workforce grant. We were when I was teaching, we were a recipient of that grant at 2022, 2023. And at the time, it was $25,000. We had matching funds from the school, so we were up to $50K. But now that AWS workforce grant is $50K, if you get matching funds, now you're up to $100K. So you can get the robot through that system. And then also you get all the software and the seat licenses through FANUC for, you know, $400,000. That's insane, $400,000 value.
Right.
I remember when we were looking at the robot we had at the school, buying seat licenses, you know, at 15 for the day class, 15 for them. So we're up to 30 licenses twice a year, you know, so 60 licenses annually. And the cost of those licenses, it was like, man, it's like, that's insane.
Yeah.
just for software.
Right.
Because you got to have it
Yep.
on each laptop, and they have to be identified because you can't transfer that program from this laptop to this desktop and vice versa. It has to stay on that unit.
Yeah. Yeah. So FANUC has done a great job. They're in about 1,800 schools right now. And they've done a great job of using the grant and helping people use the grant in the right way. AWS, I work with Monica a lot, and Monica does a great job on their funding that'll help. Um, so everything, I think everything just helps. And then we've also got all the curriculum written through our ITA or Industry Training Academy LMS. That can all be downloaded on using a SCORM file to whatever the school's using. So that's all done. Can also work with Miller Open Book, and we can work with AWS's curriculum as well, and it all goes together. The other thing that's really important on that is your certifications. What is a student getting? What's the difference between a certification and a certificate? Well, a certificate is I have T-ball kids, and they all got a trophy at the end of the year because they completed it, right? A
Mhm.
certificate is nothing more than a certificate of completion. But a certification is different. And when you're looking at a AWS certification or a FANUC certification, that's got value and weight to it for that student to go into John Deere or to go into General Motors or to go into Ford or to go into that fab shop and understand that. And so a school in the FANUC world with the equipment and doing things right in the grant can become what's called a cert school. And when they get qualified as a cert school, they send their instructor to FANUC for training. Now they can issue those FANUC certifications to the students, and the students leaves their program with a FANUC certification, robot programming certification, ARC tool certification, which is just huge. It's not a certificate of completion from a 2-year college. It's actually a certification from FANUC.
That means you get the know-how and the ability to actually step in there and start operating that robot, not just you attended class and you met the bare minimum requirements.
That's right.
Yeah,
That's exactly right.
huge
Yeah.
difference between certificate and certification.
Yeah.
A lot of folks ask about that. Hey, when I leave, do I get a certification? No, you get a certificate. You have the option to obtain certifications while you're in the program. It's up to you whether you can obtain them or not.
Yeah. 100%. 100%. It's well worth the weight of that what that certification holds. On the industry or on the mechatronics side or the material handling side, it's the same way. Do you get a Rockwell certification and a FANUC certification? Those are two great big companies that offer certifications through our equipment. And then on the welding side, you can get AWS certifications, you can get FANUC certifications, and it holds a lot of weight for that student. And that's why the student's going to school. That's why they're going to that school, is to get that job, that high paying job, which is just incredible.
Yeah, I mean, at the end of the day, that was my job as a welding instructor, not only to train the students and get them employment ready, but also help them obtain employment upon successful completion of the program. So
Right.
that makes my life easier when they're qualified and certified to be able to do that. It's easier to sell that student to a company, and then they can show up and actually demonstrate their abilities. You get that pipeline, and it's like you were saying earlier. If you go to a store and you buy a dozen eggs and you get home and they're rotten, you're not going back to that store. So I always made sure people were coming back to my store to buy my product at the end of the day.
Yeah.
And the better you can get them, the more skilled up, the better you can train them, the more people you're going to have shopping at your store, essentially. And it makes your life easier.
Yep.
Now, for an instructor, because I think that the average age in the welding industry is roughly 55. That's probably about the same as it is in education. It's either you have very, very young instructors or elderly. I don't want to say elderly, but you have older instructors, people that have retired from industry that haven't worked with cobots, and they're intimidated by that technology. Now, what sort of training is available for them to kind of ease them into adopting this technology? Because a lot of folks that been doing stick welding for the past 20, 30 years, they get into a program, they're like, now all of a sudden I have to teach automation, and I've been using
Mhm.
one of the most archaic processes in the industry for the last 30 years. How do I bridge that gap?
Yep. So there's a couple things. First off, if you're going to become a cert school, then I believe it's either one instructor or two instructors. Part of that package, that grant, is for them to go to FANUC for free for their training, and that's going through ARC Tool class. Now, there's in the material handling side, it's called handling tool, and in the welding side, it's called art tool. The Monday, Tuesday, and Wednesday are almost identical classes. The difference is Thursday and Friday we're welding, or Thursday and Friday we're opening and closing a gripper, right? In the handling tool, we're picking up a box. In the welding, we're turning a torch on, torch off. And so then they get certified so to begin with, just to teach, that's the beginning of it. If they bought our mod weld and the cobot welding, we also offer a class here, and it's a 3-day class just on manipulating the cobot on the system. And so how to weld with it, what's the communication between the power supply and the robot, how do I do a stitch weld? And it's a 3-day class here at APT. We're in Northwest Ohio, really close to Fort Wayne, Indiana. So those are the 2 classes that's available for the instructor to get started. If they're going to go down the collaborative world, would they really need to go to FANUC and APT? The answer is yes, because they want to use the Teach Pennant and the tablet. I'm going to teach them how to use the tablet side and how to weld with a cobot, but they're going to have a John Deere, a Caterpillar, a JLG lift, automotive in their area that they also need to teach from the Teach Pennant, and that's going to be taught at FANUC. There's a lot of different locations, but the main one is their headquarters in Detroit.
I was going to ask you where they're located because I believe FANUC's a Canadian company, correct?
No, FANUC's a Japanese company.
Really?
And yeah, FANUC. So a little history on FANUC that you may or may not know is FANUC is one of the largest servo motor companies in the world, and they're also one of the largest software companies in the world.
Really?
And so they were started in the 1960s building servo motors. And if you want to sell more servo motors, let's learn to manipulate them. So they built their CNC controls. In the CNC world, when I grew up in the CNC world, they called it FANUC. And in the robot world, we called it FANUC. It's the same company. And when I went to Japan to the headquarters, they call it FANUC. So I guess it's FANUC, okay. But it's the same company. And then in the around 1982 or so, General Motors went to FANUC and said, we'd like to build paint robots. Would you partner with us? And it was called GMF, General Motors FANUC. And so it was from 82 to 92, it was GMF. And FANUC in 1992 bought their shares away from General Motors because they also wanted to sell to Ford and Chrysler, and it just became FANUC Robotics. Today, Mike Chico is the president, and when he was taken over, it was around 2013, 2014, it became FANUC 1, and then it just became FANUC America. So it's no longer FANUC Robotics, FANUC CNC, it's just FANUC America. But what is FANUC? FANUC is the largest servo motor company in the world, and their software, they're one of the largest software companies in the world. They know how to move those 6 servo motors that they put in these castings called robots. And that's where it all came from. And so today in Rochester Hills in Detroit, they've got about 2.3 million square feet under roof. They build all of the paint robots for all of the world right here in Rochester Hills in Detroit.
Wow, I had no idea.
Yeah, it's incredible.
They were based out of Canada.
No, always been Japan, and then they came to the United States and did a headquarters here. The headquarters for the CNC used to be Chicago, and that's when there was a CNC group and a robotics group. That all got combined, and I don't know, somewhere around 2013, 2014, 2015 into just FANUC America, and all of the headquarters is in Rochester Hills.
I got you. Now, Anthony, when it comes to training, let's say I'm a welding instructor, I've got a group of students, I've got to teach them, stick, MIG, TIG, flux core, oxyacetylene, plasma cutting. Each one of these modules has a set hour limit of, classroom structure and then, hands-on training and then, some room for certification. What does that look like if I want to start incorporating robotics into my program? How much time out of that curriculum is it going to take to teach them the fundamentals, basics, and safety of robotics, get them out there, get them some hands-on training, and then, also provide some time for certification?
Yep. Okay, that's I've had that conversation with a lot of schools, and they say, how do I incorporate that and what do I do? My class is already full. Mm-hmm. So what I suggest to them is to start in the hand welding world up to a certain point. So at a certain point, you went from learning how to MIG weld to now learning how to TIG weld, to now learning how to pipe weld, to now learning how to do underwater welding or whatever it is. But at a certain point, a student needs to continue on to TIG. So draw the line after the MIG, draw the line in the sand and say, okay, if you want to do pipe welding, we will continue on. We'll do TIG and we'll do pipe welding. However, we now have this cobot robot class as well. So at that same point, we drew the line in the sand. We can go over to the fundamentals of cobot or robot welding. And they really need about a 20-hour class to get through the basics of that and to be pretty good and make that decision that this is an avenue I want to go to. So normally that's what I suggest is they're not going to start off in robotic welding or cobot welding. They're actually going to start off in hand welding. They got to understand the power supply. Back to the beginning of the podcast, I said the best cobot programmer is a welder. We still want to start them off as a welder. But at a certain point, we want to draw the line in the sand and decide which avenue of welding do they want to go to. And cobot/robot welding is an avenue no different than TIG, no different than pipe.
So it just becomes a new pathway within the program.
It does. Yep.
Okay. Yeah,
Yep.
I was wondering because like the program that I was teaching, we had 1,050 hours to teach students between, we had a level 1 and a level 2. So at that level 2, when they come in for the advanced processes, that'd be a good time to kind of put that fork in the road and say, if you want to travel down the traditional lane, you can go this way. If you really want to get into manufacturing, I suggest learning the automation robotic path. You can go down this path as well.
Yep. That's exactly right. And when I talk to students about the automation world, I say you got a couple choices. You can build equipment from scratch. You're going to be an integrator or work for an integrator. And there's in the FANUC world, I think there's 1,200 integrators. We all need help. Or you can work for our customers. So whoever's buying my equipment, they also need help to maintain it, set it up for new jobs. The fab shops, and you're doing collaborative robot programming. The fab shops, every day is a new job. Every day we're doing something different. And it could have an aux axis on it, which an aux axis is an auxiliary axis, which means I have six servo motors on my robot. Now I can add a FANUC 7th servo robot or a FANUC 8th servo motor or an 8th servo motor. And now the robot says, oh, I have 8 of these to move. So now I can rotate the part as I'm welding it. I can do coordinated motion. I can rotate and then weld. So those are all a little more advanced. And when you get into the laser, seam track, seam find, those are a little more advanced as well. But the basic robot programming, you're exactly right. Draw the line in the sand, give it another option of where the student wants to go.
I got you. Yeah, I seen they're using a lot of those 7th and 8th axis for doing additive manufacturing. So when they're actually doing 3D printed material using a welding process versus just like layering, they're actually using weld metal and coming out with fantastic results and replicating parts that, they put them through all these NDT measures and they're passing and passing all the tests and everything like that. So it's really cool to see how they're integrating that now, because a lot of these students, they're going to have 3D printers at home. So they're going to understand some of the basics of, programming. So I think that's also going to help and drive interest down that path to say, okay, yeah, you got like a 18 by 18 inch cell at the house, come check out this 50-inch arm that can do something very similar to that and more.
Yeah.
Kind of take it to the next level. Now, how many, for the folks that are listening, they've got a classroom. We already talked about kind of the cost of a robot. How many robots do you recommend, or how many students per cell? Is like,
so normally we're running 2 to 3 students per cell.
Okay.
So it depends how many different classes they have. Are they evening classes, day classes? Usually I see that a school says, we're just going to go get into this. We're just going to buy one cell. And within a year or so after they've started advertising the class and they're getting students in, they're buying the second and third cell.
Okay. That was my big question, because we integrated virtual welding technology.
Mm-hmm.
And so we bought a virtual welding cell, which is great, but I mean, again, that cost is almost $100,000.
Mm-hmm.
And you can only run like 2 students at a time through it. And it's like, okay, this is great, but when I have 20 students and one piece of equipment, not everybody's getting access to that equipment equally.
That's right. Yep. So they need to be rotated around. But most of the schools that we work with start as, I'm just going to order one and see if I can even get students in this class. Very shortly, they realize the class is filling up. Like, well, I've got 10 students. I need 2 more of these or 3 more of these systems. Yeah.
Okay, fantastic. Well, Anthony, it's been an absolute pleasure having you on the show again. It was great meeting you up at in Minneapolis for the Welding Automation Conference. Thank you for so much for taking time out of your day. I know you're a busy guy. You guys are just getting back into the swing of things, gearing up for the fall semester here pretty soon. So thank you for coming out and sharing information all about manufacturing and automation.
You're welcome. And if anybody has any questions for me, they're more than welcome to reach out to me. They can go to our website, aptmfg.com, and fill out a contact form and say, hey, I listened to Tony. I got questions. How do I get started? I'm in whatever state or whatever school or whatever I'm doing, and we'd be glad to just talk to them. I'm not here to sell anything. I'm really here because I have a passion for it. And yes, I have equipment that sells, but I absolutely want to help people. If industry wants to call me and talk to me about an apprenticeship program, how do I partner with a school? How do I start an apprenticeship program? I would love to talk to industry about an apprenticeship program.
I think that's the biggest thing we need is more push from industry. I think they have to do a better job of working with the schools because a lot of them are jumping up and down. We can't find qualified people, and it's like you could create them if you're
That's
willing
right.
to put the time in. You could go to your local school and work with them and develop a pipeline or an apprenticeship program, and have some involvement, get some face time with the students, develop that rapport and relationship, and you can create your own workforce. And a lot
Yeah.
of them, they're just not putting that link together. And that's one of the things I always try to do as an educator: say, hey, I can teach them the fundamentals and basics. If you pull them out of my class, I know they don't have the 5 to 7 years worth of work experience you're looking for, but you can train them how to do it is what you do and give them the opportunity. And you're going to have a faithful employee that doesn't know how to do it wrong because you're the one that trained them.
100%. I agree. I have such a passion for apprenticeship programs. I think every industry should have an apprenticeship program.
I'm 100%
You
with you.
already spend money training as soon as you hire somebody. Why not partner with your local community college or your local career center, your local technical school, your local university, and partner with them through your state? I have a state certified apprenticeship program. The students go through it. They get a certification that they've completed the apprenticeship program, which is 2,000 some hours of work hours a year, plus 2 nights a week at
Yeah,
school.
that's fantastic. I think every program or every industry should have an apprenticeship program. I think that's one of the things that they got left in the days gone by that we need to bring back seriously. For the amount of labor that we need right now, especially qualified labor, is through apprenticeships, because at that point you have checks and balances and goals, and students and people or apprentices in the program, they actually have a pathway to get to become a journeyman in that field.
Right. Absolutely. Absolutely.
Awesome, Anthony. Once again, it was a pleasure having you out on the show.
Thanks, Jason. Thanks for the invite. I appreciate it. Have a great day.
Yes, sir. You as well.
All right, ladies and gentlemen, that's going to wrap up this month's edition of Weld Wednesdays with AWS. Huge thanks to the American Welding Society for continuing to support education, standards, and the people who keep this industry moving forward. The AWS exists to support welders, inspectors, educators, and fabricators at every stage of their career. And if you're serious about sharpening your skills, advancing your career, or getting more involved with the welding community, AWS.org is where it starts. Thank you all so much for listening. Thanks for sharing the show, and thanks for being part of a trade built on skill, discipline, and pride. I hope you'll have a great rest of your month. Stay safe out there, and until next time, make every weld better than your last.